go.
LD sub.
LD sub is go.
That concludes the go, no-go sequence. We are T-minus 11 minutes, 20 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
That was Launch Director Joseph Carpico at the end of that go, no-go poll, confirming that the team is happy to move forward to liftoff. I want to give a special shout out to Mr. Carpico today as well, because this mission will be his 100th launch, which is just an incredible career milestone. He joined Rocket Lab with over 50 launches under his belt from his time in the US Air Force and the then Hughes Space and Communications Company, as well as launches with the Sea Launch Program and the Antares Launch Program. His contribution to our Electron launches since 2019 brings his launch tally up to 100 today, and we couldn't be prouder of Joe or more thankful for his dedication and service to the space industry. And so it's only right that he is today's launch director and whose voice you will hear behind today's 10-second launch countdown to liftoff.
It's set to be a busy year of Electron launches with a sold-out 2024 launch manifest. But it is also an exciting time in our space systems businesses, where we build satellites and their components for missions that make drugs in space and conduct science experiments on Mars. With more Rocket Lab spacecraft in build and backlog than ever before, this year is also set to be a mammoth year for our space systems teams across the world. Let's take a look at what they're getting up to across our facilities. We're building satellites at scale. We might have started with rockets, but today, Rocket Lab is a major space prime. We're designing, manufacturing, and operating satellites for government and commercial customers. It all starts with mission design. We partner with our customers to develop tailored spacecraft solutions. Starting with reliable, flight-proven spacecraft platforms, we tailor each spacecraft to each individual mission's requirements. Whether it's a science mission to study our solar system's planets, a technology demonstration in low Earth orbit, or a constellation enabling communications or national security, we are building satellites that make it possible. They're manufactured at our spacecraft production facilities, home to a 12,000 square foot state-of-the-art clean room and more than 40,000 square feet of streamlined production and test facilities designed to support constellation-class manufacturing and satellite assembly, integration, and test. We've been intentional in developing a vertically integrated supply chain for our satellites, manufacturing components, subsystems, and software in-house to drive efficiency, accelerate production timelines, and deliver cost savings. This means Rocket Lab spacecraft incorporate flight-proven star trackers, propulsion, reaction wheels, solar cells, panels, and arrays, flight and ground software, radios, avionics, composite structures and tanks, and separation systems. And our customers know they can rely on these, since Rocket Lab components and subsystems have flown successfully on 1,700 missions globally and counting. Following final assembly, integration, and test, we ship the completed satellites to the launch site for integration to the launch vehicle, whether that's Electron, Neutron, or an entirely different rocket. Once launched, we have global ground station coverage, enabling our customers to communicate, downlink, and process data from their satellites thanks to our satellite operation centers in Long Beach, California, Auckland, New Zealand, and Littleton, Colorado. With more than 40 Rocket Lab satellites in development across our factories right now, there's more than just rockets in this lab. On top of this, just a few weeks ago, we announced our biggest space systems contract ever, a $500 million agreement with the Space Development Agency to design and build 18 satellites for their LEO constellation known as the Transport Layer. This constellation provides assured, resilient, and low-latency military data and global connectivity to meet the DoD's needs. Work has already begun on building these 18 satellites, which are made up of subsystems and components we produce in-house, just like you saw. SDA's approach to building out this constellation favors speed, schedule certainty, and affordability. We've proven ourselves of this across our launches and other spacecraft programs and are now ready to deliver on this for the SDA.
We are now 6 minutes and 18 seconds and counting to liftoff for tonight's four-of-a-kind mission. Now, tonight's pre-launch operations will follow much of the same process as a standard Electron launch you may have seen before, but with today's launch doubling as a recovery mission, it's after liftoff when you can expect to see changes in the mission profile. 2 minutes before launch, Electron will switch to internal power and enable its onboard launch safety system called the AFTS, or the Autonomous Flight Termination System. This puts safety control in the hands of the rocket's computer, which has a pre-programmed set of safety parameters that Electron must fly within. Anything outside of those bounds, then the AFTS can issue a command to terminate the mission. Now, Mission Control will call out both of these actions across the nets. At under a minute to liftoff, the propellant tanks will be at their optimum pressure levels for launch. Ground control will then confirm the water deluge system on the pad is ready to be activated for when the engines on the rocket ignite for launch. And this is what causes the large white cloud of water vapor that you see at liftoff. Then we get to T-minus 10 seconds and the launch director counting down with the launch clock. Then the engines will ignite at T-minus 3 seconds and the launch pad's hold down mechanisms will be released for Electron to take flight at T0.
Now, from liftoff, Electron's first stage will burn for about 2.5 minutes, propelling the rocket past supersonic speeds and through a launch milestone called Max Q, a critical pressure point during ascent. We then come to MECO, or main engine cutoff, when we switch off those 9 Rutherford engines and separate the booster from the second stage. When the second stage's sole engine lights up to carry on with the mission, it is at this point that our recovery operations begin for Electron's first stage. After an orientation adjustment, the booster will descend back towards Earth, and we can track its progress through the onboard camera for as long as we can, though be warned that the camera may be expected to cut out at some point during that descent.
Now, while all of that is happening, the second stage with Spire and Northstar satellites will be going through their own series of events. The rocket's fairing, or the nose cone, will split and fall away, and we'll also hear Mission Control call out battery hot swap for when the second stage's power system switches to new batteries for the engine's motor controllers. At the end of the second stage's 7 minutes of flight, we'll have another engine cutoff, and then Electron's kick stage, which the satellites are attached to, will separate.
Now, alongside all of that, Electron's first stage will be continuing its journey back to Earth. The first stage is expected to deploy its first parachute at about 7 minutes after liftoff. While we might not see that happen on screen, we should still hear the call out from our operators in Mission Control. This will help reduce the stage to subsonic speeds before the main parachute is deployed at about 8 minutes into the mission. Splashdown will then occur at about 10 minutes after that main chute deploys. Once that's confirmed, our recovery team will move in and get to work to bring Electron up onto the deck of their recovery ship, do their initial assessments, and then strap it in for a secure ride back home to land.
And again, while all of that is happening, our primary mission will continue. It takes about 40 minutes or so after the kick stage has separated for it to complete an elliptical orbit of Earth. We want to deploy the satellites in a circular orbit, so once this elliptical trip is complete, the kick stage's engine will circularize our orbit. That takes only a couple of minutes before the trajectory is set and the satellites are ready for departure. And then it's about 90 seconds or so to deploy all 4 LEMUR payloads because they'll leave their deployers 2 at a time. We'll have an animation of that payload deployment process to talk you through when it happens, so make sure to stick around or join us again after liftoff for those final moments of the mission.
We are now just 2.5 minutes away from liftoff of Electron. We're going to hand it over now to Mission Control to take us through the rest of the countdown, and then Muriel and I will be back with you after liftoff as the mission makes its way through those milestones. Go four of a kind, go Electron, and go Spire and Northstar.
Vehicles on internal power. AFTS is green and able to flight.
Lock system is in recirculation. Anti-geyser has been disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
Glow engine purge is enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4,
3, 2, ignition, and liftoff.
And we have liftoff.
Electron has successfully lifted off from Rocket
Stage
Lab
1
Launch
propulsion is
Complex 1 with its Spire and Northstar payload. The rocket is on its way to low Earth orbit with those 4 satellites on board, now T plus 40 seconds into flight. Electron has begun its pitch over, moving up and on an angle to head away from the launch pad and out over the ocean. Now all is looking nominal so far as the rocket approaches max Q, the moment in ascent when Electron experiences the maximum amount of aerodynamic pressure.
Electron is supersonic, approaching max Q. Cleared max Q.
A good call out from Mission Control there that Electron has cleared max Q. The rocket is now 16 kilometers in altitude and moving at over 2,000 kilometers an hour, which you can track the mission's progress by that telemetry dials at the top right-hand corner of your screen.
Next up for Electron is MECO, or main engine cutoff, quickly followed by stage separation and the startup of the Rutherford engine on that second stage to continue the mission to orbit. The 9 engines of the first stage will throttle down and then shut off just before the first and second stages separate from each other. When that happens, the second stage with the Spire satellites will maintain its orbital trajectory and continue on with the mission, while the first stage of Electron will begin its reorientation maneuver to position itself for the return journey to Earth. Now, these 4 events happen in quick succession and are coming up shortly.
15 seconds to staging.
Entered burnout detect mode. MECO confirmed.
That's confirmation of MECO, stage step, and Rutherford engine ignition on stage 2. The telemetry dials at the top of your screen continue to show the speed and altitude of the second stage for the primary mission, with the stage 2 nozzle glowing bright above the stunning Earth.
Stage 2 propulsion nominal.
For fairing jettison on the second stage, which you saw there for yourself, that means Electron's nose cone has successfully split apart and fallen away. And we do this in preparation for deploying the kick stage with its satellites and to get rid of the dead weight of the fairing now that we are through Earth's atmosphere. we have got the trajectory graph showing on your left-hand side and on the right-hand side, which track the stage's current altitude, matching the nominal altitude that we need to reach orbit. Its momentum arc, and once it reaches this apogee, the stage's trajectory line should start to come down as its altitude begins to drop too. You are seeing, though, on your screen that movement of the booster as it redirects to come back to Earth bottom heavy. That way, the engines bear the brunt of the re-entry forces rather than shredding the carbon composite at the top of the stage. The stage will move quickly as it is pulled back to Earth by gravity, and at its peak, the first stage will reach around 8 times the speed of sound and generate so much friction that we could see a red-orange glow from the heat as it descends. It is T plus 4 minutes and 33 seconds into the mission, and Electron's second stage carrying today's payloads remains on course for payload deployment within the hour. Now that second stage is clocking speeds at more than 10,000 kilometers an hour, having now passed 174 kilometers in altitude. For Electron's first stage, on its return journey back to Earth, we have had the stage reach its apogee, flip into its atmosphere re-entry position, and begin dropping in altitude as it speeds up on its homeward-bound trajectory. It will travel this way for a few minutes before its drogue and main parachutes are deployed to help slow it down.
The end of Stage 2 may look a little different than what you're used to from our previous launches, but this is due to the implementation of BEAST, or our electrical arc suppression system, which ensures all electronics on board can function nominally. In particular, you might notice the addition of a nitrogen tank that maintains pressure within the stage. We're now listening to hear the call from Mission Control for battery hot swap. This hot swap maneuver will allow the continuous energy supply to the Rutherford engine's electric pumps, which deliver fuel to the engine's combustion chamber at extremely high pressure.
Hot swap successful.
A good call from Mission Control. Electron's second stage has completed the battery hot swap. The second stage is maintaining its momentum at more than 15,000 kilometers an hour, now past 200 kilometers in altitude.
And we are currently at T plus 6 minutes, 39 seconds into the mission, and the next critical milestone we are tracking is the deployment of the drogue chute on Electron's first stage. Watch that left-hand side of your screen.
AFDS has saved.
Confirm drogue deploy.
As you can see on your screen there, a fantastic view that we have the drogue parachute. It has been deployed from that first stage of Electron. We heard that call from Mission Control as well, so that seems like a nominal drogue chute deploy since we haven't heard anything different from our operators. That means we'll move next to the main parachute deploy, coming up in around 30 seconds, which we should also hopefully see happen from that live camera feed on Stage 1.
Main parachute deploy.
HVB battery discharge, holding nominal.
Another great call out from Mission Control. The main parachute on Electron's first stage has successfully deployed. This means the booster's pace will have slowed down significantly and should now be drifting gently towards the ocean. It's expected to take around 10 minutes for the booster to reach the water surface, but we'll keep the comms channels up from Mission Control to share updates as they come through.
Enter burnout detect mode.
Guidance is in terminal, 26 seconds remaining.
Now back to the primary mission, and we are coming up on the final few seconds of stage 2 engine burn. We will then have second engine cutoff, or SECO, which shuts down the engine ahead of the kick stage separating for its phasing orbit of Earth. And we're listening out for those events now.
SECO confirmed. Stage 3 separation confirmed.
Great news from Mission Control with that second stage engine cold and the kick stage separated. We are now in the final stages of this 4 of a kind. After that elliptical orbit of Earth is complete, then the kick stage's engine will light up to set the stage and the satellites on a circular orbit before payload deployment. The stage's coast phase will last about 40 minutes or so, and then there is payload deployment before we can call mission success for Electron's 43rd launch.
Before we break, though, the latest on recovery is that all is continuing as planned for Electron's first stage and its slow descent to the ocean. Our recovery crew are on standby in the recovery zone, waiting for that splashdown before they can move in and get to work.
Take a bit of a break now on the webcast, but we will come back to you in a few minutes with confirmation of that booster splashdown when we hear it. So we'll leave the audio channels up so we can listen in for that in real time from Mission Control. Otherwise, we will see you back here shortly.
Hello and welcome back to the webcast for our 43rd Electron mission, 4 of a kind, a dedicated launch for Spire and Northstar Earth and Space. We have had a perfect mission so far to deliver today's payloads to a 530-kilometer low Earth orbit and smooth operations for Electron recovery.
Electron cleared the pad at Launch Complex 1 at 19:34 New Zealand local time and soared cleanly through its first launch milestones. That's max Q, MECO, stage separation and second stage ignition. And shortly after that, the rocket completed a successful battery hot swap for its stage 2 engine before the Rutherford shutdown is planned for kick stage separation.
While all of that was going on, we have, of course, had a secondary mission underway to bring Electron's first stage back to Earth from space. After a clean separation of the first stage after MECO, the booster had a great return journey through Earth's atmosphere with successful operation of its onboard reaction control thrusters to correct the stage's return trajectory. Falling fast, the first stage hit peak speeds of about 8 times the speed of sound and some intensely high temperatures from atmospheric drag.
Having survived that hard and fast journey, we had successful deployment of the first stage's 2 parachutes to help slow Electron down to just 10 meters per second. Electron has since successfully splashed down, and our team are deep in recovery mode to pull that booster out of the water and up on deck. Once it is on board, they'll desalt the vehicle as much as they can to preserve the stage for its trip home to land and to the factory.
Right now, though, we are just seconds away from Curie engine shutdown on Electron's kick stage and the beginning of the payload deployment process. We should be hearing the call for engine shutdown shortly, so let's listen in.
Curie engine cutoff confirmed.
Apogee at 531.2 kilometers, perigee at 529.8 kilometers, and an inclination of 97.490 degrees.
Good comms from Mission Control there. That Curie engine has shut down ahead of payload deployment in the next 30 seconds.
recovery team are busy securing Electron's booster on the boat for the return journey back to our factory. We'll keep you posted on how that goes, so keep an eye out on our social media pages for more information on our secondary mission. We're going to end the broadcast now, but we are very, very excited for what is coming this year for Electron, Space Systems, and Neutron. The Rocket Lab team around the world are hard at work reaching milestone after milestone, and what a way to kick off 2024 with a successful launch and recovery.
So, for the first of many times this year, thank you for joining us. This is Rocket Lab Mission Control signing off.